This video playlist provides a tutorial of the Azore CFD software to post-process results from a flow simulation. The Complex Duct CFD simulation represents a heating and air conditioning duct system for a building. Flow for the HVAC system enters through a single model inlet shown at left. The flow then splits to two branches, one on the first floor and one on the second floor of the building. There are 4 outlet vents per floor, and the ductwork features a variety of geometry elements, including contractions, curved elbows, square elbows, T-junctions, and Y-junctions. The goal of this CFD model is to predict the flow patterns within the ductwork, along with the flow split to each of the 8 outlets and the overall pressure drop. There are 8 total videos for the Complex Duct post-processing tutorial, and a written version of this tutorial is included with the Azore software as a PDF file. Step 1 of the Complex Duct post-processing tutorial is to launch the Azore software from the desktop icon. The Azore graphical interface allows you to set up a CFD simulation, run the Azore solver, and post-process results. The menu structure at the top of the Azore window shows the main menu options. For this tutorial, we will start with an existing Azore database and analyze the results from the already completed simulation. Under File, Open Database All, we will navigate to the Azore Tutorials folder and select the Complex Duct Post-Processing Database directory. At the left side of the window are the display controls. The model render area shows a wireframe of the complex duct system. The model can be rotated by pressing and holding the left mouse button while moving the mouse in the render area. With the Edges tab active and Wall 0 selected, we only see the features of the mesh. Selecting Outline shows only the inlet and outlet openings of Wall 0. Selecting All Mesh shows the entire surface mesh. We will return to viewing just the features of the complex duct. We can change the color of the features by selecting the Color button. Unselecting Wall 0 will display a blank model render area. Selecting Pressure and Generate will display all of the outlet surfaces. Selecting Exterior displays all exterior surfaces. We will change the render type to All Mesh. Next, we will uncheck Apply to All and click Clear. We will then select only the Outlet 2 surface and change the color. Right-clicking on the Color button brings up a different selection menu. Selecting additional surfaces will change those surfaces to the same color as Outlet 2. We will then press Clear and change only the Wall 0 surface back to Features. We will clear again and change the inlet surface to a different color. With inlet still selected, we will right-click on one of the outlet surfaces and choose Select All with Same Properties. By rechecking Apply to All surfaces will then be set to the most recently chosen options. After returning the display of edges to be only Wall 0 rendered as features in white, we will then switch to the Faces tab. Face color should be set to By Type. We will then select Exterior, and the faces will display the default color for their type. We can adjust the color, opacity, and the lighting of the faces. Next, we will change face color to By Surface, and then uncheck Apply to All. We can adjust the color, opacity, and lighting for individual surfaces. Right-clicking on lighting can turn lighting on and off for all surfaces. When the Paths tab is selected, Initialize Paths needs to be pressed to calculate the necessary data. We will select Flow and generate the two inlet surfaces. We can uncheck Distribute to adjust the number of path lines displayed. We will then select Field and change the path line's shape to cylinders. To view movement, we will press the Go button. Alternatively, we can click on Options and Animate to show movement. We can adjust the options to affect the flow movement through the system. The Stats button can be selected to summarize time and distance statistics in the log message area for the path lines. The two arrow buttons control the undo and redo functionality. To finish this example, we will turn off the display of faces and return the display of edges to be only wall 0 rendered as features in white. Under the Contours tab, we will select the surface Interior 1, 2. We will change the field selection to Total Velocity and then check Display Range to change the limits of the range on this surface. Next, we will change the units to feet per second. This change can be seen on the color bar. Then we will change the category to Pressure and the field to Total Pressure. We will start by positioning the model in the Y-axis Z-up view. Next, we will create a cutting plane through the center line of the upper ductwork by pressing Shift and the right mouse button while holding and dragging the line that appears. After we release the line, we will confirm the cutting plane coordinates. Next, we will select this new surface, Default Plane 0, in the Contours tab and press Generate. Rotate the model to visualize the new plane. We will then select the velocity category and total velocity field. We will set the range to be 0 to 50 feet per second. To add vectors, we will select the plane in the Vectors tab. We will decrease the distribute value to reduce the vector grid spacing. We will also check in plane to view the vectors on the plane instead of in 3D. To extract numerical data from the simulation results, we will start by activating the Surface Data tool. We can first select the interior 1-2 surface, and Azore will report a number of quantities in the log messages area. For more specific information, we can select Outlet 4 and choose Mass Flow to report the mass flow value at this outlet. We can also request the area weighted velocity on the interior 1-2 surface. When we are finished, we can save the database and close out.